This is lesson 7.2. We're still going to be looking at exponential growth and decay. However, we're going to adjust our formula slightly in order to look at compound interest. Today's learning targets are: given context, I can write and evaluate a compound interest equation, and I can solve simple exponential equations algebraically and using intersections. So this is still an exponential equation. However, it is tweaked slightly to be compound interest. So if you look here, we still have our total, our final value is here, what it equals. P is our principal, because we're talking about compound interest, we're talking about money, so we have it as our principal, but it's still just our initial value here. This is going to be our multiplier. So our multiplier here is 1 plus r over n. R is going to be our annual interest rate, and n is going to be the number of times the interest is compounded, because it is compound interest, and then t is still going to be time. So we still have an exponent, we still have a multiplier, and we still have an initial value. We just have a couple additional pieces that we have to add. So compound interest compounds on itself a certain amount of time. So if it was compounded, your interest was annually would just be one time. So that would be like in our last equation, what we were looking at for that n value. Semi-annually or biannually would be twice a year. Quarterly would be 4 times, monthly 12, and daily 365 times. So if it means that we're either annually once taking our amount that we have in our bank or our principal, and we're creating interest on that. Semi-annually, we would be doing that twice a year, and quarterly 4 times. Monthly, you would do it each month. Whatever you have in your account, each month interest is being applied to that. And daily, each day, whatever you have in your account, that interest is being applied. So our first example, it says find the total amount the investment is worth when you invest $2,000 into a 4-year CD that has 4.25% interest compounded monthly. So we have to find each of these values to plug into our compound interest equation. So here we are looking for our total amount. So this is what we're trying to find. So that is going to be our variable. So our final amount after a certain amount of time is what we're solving for. Our principal, or our starting value, is going to be $2,000. And then our multiplier is 1 plus, because it is growth, it's going to increase over time. R is our rate, our interest rate. So we have 4.25% interest rate, but we want to write this as a decimal. So if we move that decimal twice, our interest rate is going to be 0.0425. So just like we did with our multiplier, we change it to a decimal. Same thing here with this percent. So you would have 0.0425 divided by the number of times it's compounding. It's compounding monthly, so that's going to be 12 times each year. So we take this interest and we divide by 12. So we have our initial value, our multiplier, and now we have our time. Our time is over 4 years, but over those 4 years, that interest is being applied 12 times. So 12 times each year. So we just want to take this now to find our final or total value and plug it into our calculator. So this is going to be our amount after 4 years. And if I plug this into my calculator, I have 2,000. And then in parentheses, I have 1 plus, and I want to put this second piece here in parentheses. So I've got a double set of parentheses. So now I have parentheses 0.0425 divided by 12. Close that inside parentheses and the outside parentheses. So I'll have two parentheses. And I'm going to raise this to 12 times 4. So I have 2,369.898 if I round. So if I want to write my final answer, my final amount is going to be a dollar amount. So it's $2,369. And if I round this, it's going to be 90 cents. So after 4 years, I've gone from $2,000 to $2,369.90. So over those 4 years, I have $369.90 I made in interest. So for example 2, we now want to find the total amount the investment is worth when you invest that same. We should have $2,000 into a 4-year CD with a 4.25% interest that is compounded quarterly. So we just want to figure out what that final amount is. Just like on that previous slide, we want to figure out what our amount is after 4 years. If we start with 2,000 and we have a growth of 4.25%, but now instead of compounded monthly, we're compounded quarterly. So 4 times a year. So that 4 times a year times over 4 years. So when we plug this into our calculator, we have 2,000 times 1 plus, and then our second set of parentheses, 0.0425 divided by 4, 2 sets of parentheses, all raised to this 4 times 4, which is 16. So we get $2,368.48. So if we compare this, since we started with the same amount and we went over 4 years, if we compare this to the last example, it's slightly less money. Where on the last example we had $2,369, now we have $2,368. Well, why is that? Because here we're compounding quarterly. So only 4 times a year are we applying that interest. Whereas in the last example, we're applying the interest 12 times each year. So the more you compound, the more money you're going to make. Now we only started off with $2,000, so we can see that it's a very small difference. However, the more money you start with, the more of a difference it's going to make how much you compound, because you're applying an interest to a much higher amount of money. So the more you compound, the more money you're going to make. So now, just like we did with just regular exponential growth and decay, we want to use this information and, well, what if we have our final amount, but we want to figure out how long is it going to take? We're going to have to solve for that exponent. So it says we want to solve for this. We want to do it in 2 ways. We can do it algebraically and we can do it graphically. So if we do this algebraically, well, our final amount is going to be 5,000. And we still start with that 2,000. We have 1 plus our interest rate, compounded quarterly. So every year, 4 times it's going to compound. So we want to figure out what is our time that it's going to take to essentially increase $3,000. Well, our goal is to solve for our exponent, so we're going to have to use logarithms. So we have to get our exponential here by itself. So to do that, we have to start by dividing by 2,000. When I divide by 2,000 on both sides, I get 2.5 equals 1 plus 0.0425 divided by 4 raised to the 4t. Well, this right here is my multiplier. It's my base of my exponential. So from here, since there's nothing out in front, nothing behind, I can change to a logarithm. So to change, I have my base of my exponential becomes the base of my log. So here I have 1 plus 0.0425 divided by 4. Now, if you added this and got a number, that works, but this is just going to be more accurate than going ahead and adding them together and rounding. Now, you can do that, but your answer will be slightly different. So this is going to be our base to the 2.5 equals our exponent. We're solving for our exponent, so our log helps us do that. So what I have to do to solve for t is, well, I have to figure out what this log is here. So to do that, I plug it into my calculator. Remember, I have one of two ways depending on my calculator. So these are essentially my two options. I have option 1 here if I have the log base in my math piece of my calculator, or I have the change of base formula. Either way, I solve for my log and I get 86.69646605, and that's equal to 4t. And to get t by itself, I'm going to have to divide by 4. So I divide by 4 on both sides, and that is my final answer. So my final answer is time is going to be 21.67 years. So essentially it's going to take me 22 years to gain $3,000 on my initial investment. So this is if I went through and solved algebraically. Now I could also use my graphing calculator and plug in both pieces to y1 and y2 to solve for my intersection. So if I do that, I want to plug in 5,000 to y1 and then my other portion to y2. So when I go ahead and type that into my calculator, this is what it would look like. I can interchange y1 and y2, so I just plug that in. So when I graph, I'm going to have to adjust my window. So if I'm in my standard view or whatever I'm in, if this is going up to 5,000, I can't see that on my standard window. So I want to adjust my window. My y values are going up to 5,000, so I want something above that. And I always want to adjust my x max. So my initial thought was that I was going to adjust my x max and x min, and I did that by my x max I just went to 50 and my y I went to 6,000. Now could you have something different? Yes, but I know hopefully with these values that I should be able to see my graph. The farther you go out, the more you're going to see. So when I do this and I adjust my window, I can now see my exponential and where it's going to cross with my final value. So I have an intersection here. And remember, to find my intersection, I hit second trace, and it's number 5, intersection. And number 5, when I hit that, I hit enter 3 times. First curve, second curve, guess. I hit enter for each of those, and it'll give me my intersection here. So it's going to intersect at 21.67, 5,000. And X is my time. So just like when I solved algebraically, I have 21.67 years until I have $5,000 in my account.